Hey Muffins, it's me again. It is now day 2 of section 13.3, so it is March the 26th. This lesson is kind of long and there's some things that we didn't get to last time, and I need to explore that with you today. And I'm covering all the information in your note packet from section 13.3, and I'm probably moving in a little bit of a different order. I am once again kind of going to go to a blank screen because I feel like I can maybe just keep this a little bit simpler. But I'm going to call this section 13.3 continued. And maybe you can look at this as day 2 with section 13.3. And what I want to talk about today is, what are you going to do when I ask you to find the sine of 180 degrees without a calculator? Again, there's going to be an issue. If you go and draw a 180 degree angle, boom, you land smack dab on the x-axis. And there is no reference angle, there is nowhere to drop a perpendicular, and you're really just kind of stuck without an option. So what I'm going to do is, over here on the side of your paper, I'm going to introduce to you this kind of a guy called a unit circle. And a unit circle is a circle that has a radius of 1. So let's just pretend for just a second. I'm going to draw a little coordinate plane with a little grid, and I'm going to put a little dot at 1, and let me see what kind of a circle I've created. Okay, he's not very straight. He's got a little issue right here, but this is kind of a unit circle. If this is the center, it's got a radius of 1, a radius of 1, a radius of 1, and a radius of 1, okay? And this would be the point 1, 0, and this would be the point 0, 1, and this would be the point -1, 0, and this would be the point 0, -1. And I think all of that kind of makes sense to you. And you're kind of like, well, I don't know why you're doing it, but that is a unit circle. And another thing that I want you to take into consideration for just a second is, let's just say I had a 30-degree angle. I'm going to draw him right here in the first quadrant, okay? If I were to drop, all right, I'm going to use that right there to let you know this is the angle I'm referring to. He doesn't have a reference angle because he is an acute angle because he's already in the first quadrant. I'm going to drop a perpendicular and create a cute little triangle right there in your first quadrant. And this is what we really were doing before spring break. All of our little angles were acute and we just stayed in a little right triangle to begin with. But now I've just drawn them in quadrant 1, which is no big deal. But if I were to act like there was a unit circle around him, if you were to go from the center out to the edge of the circle, that guy would be called a radius, which is why I'm going to mark him R. He's still the hypotenuse of that right triangle, but I'm going to refer to him as R. This side of the triangle, it is on the x-axis, so I'm going to call that side X. It is still a leg of the right triangle, and we typically use A and B to represent those, but I'm just going to call it X only because it's on the x-axis. This guy, he is parallel to the y-axis. He is not himself the y-axis, but he is going up. So that's why I'm going to refer to this guy as Y, okay? And then what I'm going to do is, based on this diagram, I'm going to write the word sine of angle theta cosine of angle theta and tangent of angle theta. And based on this diagram, sine is still opposite over hypotenuse, but that is where I get y over r. Cosine of this angle would be adjacent over hypotenuse, which would give me x over r. Tangent would be opposite over adjacent, which is where I get y over x. So I'm introducing something new to you. You've probably maybe not have encountered this yet, but this guy's a unit circle. This guy is a little triangle that I have drawn maybe inside of a unit circle, but I'm using it to show you the relationships of x and y and r and where they're coming from. And I'm going to use both of these things in order to answer this question. So here I go. The sine of 180 degrees. If I, again, draw a 180 degree angle, boom, I land smack dab right here on the x-axis. That is actually called being a quadrantal angle. So if I fall right here on this spot, that's as though I'm landing right here if I were really on a unit circle. So this little dot right here would be the point -1, 0. Okay? Then, as I look at this point, I then come across, what does sine mean? Sine means y over r. So I'm going to write down y over r. And when I use y and r, let me show you what all these are looking at. This is the x coordinate. This is the y coordinate. So the y in this problem is a 0 because the y coordinate was a 0. The radius for these problems are really the radius of the unit circle, and the radius is always equal to a 1, so that's why the r is 1. And what is 0 divided by 1? 0. So if you tell your calculator sine 180, you should get an answer of 0. And all of that is me using my knowledge of the unit circle and my little knowledge right here of this. Let's try another one of these real quick. And maybe I won't have to erase all of that to save me some time. Real quick, here I go. Let's see if I can get this right. Let's say I want to do the tangent of 270 degrees, okay? What I'm gonna do is go draw a 270 degree angle, and boom, I like to put a little dot where I land. I land smack dab on the y-axis this time. And if I were on the unit circle, that spot right there is the point 0, -1. This is the x coordinate, this is the y coordinate of that point right there. And if I consider the relationship of tangent, tangent is opposite over adjacent, which is why I'm going to need a y over an x. In this problem, the y is a -1 and the x is a 0. And -1 divided by 0 is undefined. So if you tell your calculator to do the tangent of 270, it's going to give you undefined. It's going to give you an error. It's not going to be able to give you a measurement. And it's because it's division by 0. All right, let's do another one of these. Okay, this time let's go crazy. Let's do the secant of 90 degrees. Oh my goodness. Remember, secant is the reciprocal to cosine, okay? So if I go ahead and look over here at cosine, if cosine is x over r, then the reciprocal would be r over x. So maybe I'm jumping the gun a little bit, but secant is reciprocal to cosine. So I'm gonna draw a 90-degree angle. Boom, and I land right there. And if I were on the unit circle, that's that point right there. This is the point 0, 1. This is the x coordinate, this is the y coordinate. And remember, the radius is always a positive 1. So the radius in this problem is a 1. The x in this problem is a 0. So once again, if you were to do the secant of 90 degrees, you would get an undefined answer. But you don't have a secant button on your calculator. So if you were to do 1 divided by the cosine of 90, your calculator will tell you that it's undefined or give you an error. And again, the whole point of these particular problems are, these are evaluating trig functions for angles that are quadrantal. They fall directly on the x and y axis. So if I ask you to evaluate this without a calculator, you're not going to have that as easy as it would be. But I wanted to introduce to you today what a unit circle was, what this little triangle was, and how the letters X, Y, and R relate to all of this, and how to kind of evaluate a trig function for an angle that's quadrantal. And I'm going to try to do maybe 1 or 2 more of these to hopefully get y'all to catch on a little bit. Okay, here we go. Let's try it again. Let's go one color. Let's do lightweight. Okay, so now what if I do, I haven't done cosine yet. Let's do the cosine of 180 degrees. Let's just try it. So I'm going to draw the angle again. Boom. And I land right there on the x-axis, which again is right there on that point right there. So that would be a negative 1, 0. Cosine is going to follow adjacent over hypotenuse, which is x over r. So the x in this problem is a negative 1. The radius for all of these problems is a positive 1 because the radius is 1 for everything in a unit circle, and negative 1 divided by 1 is negative 1. So maybe this helps you try to understand how to evaluate an angle that's quadrantal, okay? The other thing that I would like to